Hey, what's up, students? This is Wednesday, the 28th of April. We're going to rock through this factoring trinomials day 4 lesson. So I want to just start with our do first here, take a chance to look at finding the greatest common factor of these 5 cards, and then go ahead and match that. So take a moment, pause, try that out if you haven't already, and then I'll be back to walk you through it. Did you pause? Did you try it? How'd you do? Well, if you didn't get it, let's walk through this here. So the idea behind it is we want to say what is the greatest common factor that they have possible. So if we look at this number 12 and 20, we're really saying which number can go into 12 and 20, the biggest number possible. And 12 I can divide by 12, by 6, by 4, by 3, by 2, by 1. And 20 I can divide by 20, 10, 5, 4, 2, and 1. So the biggest number, if you list out all those factors, is going to be 4. 4 goes into both 12 and 20. And then if I have x and x squared, I can divide by x. And if I have y squared and y, I can divide by y. So your first answer should be this. All right. Same idea with 5x squared and 10x squared. What's the biggest number that can go into both 5 and 10? It's 5. The biggest number that can go into x squared and x to the third is x squared. All right, now that you got those two, do the rest of these make sense? Try them out. 10 and 25, it would be 5x. Pause at any time to try them yourself. 12 and 24, it's going to be 12. xy squared, I can pull out an xy. And then this last one, 4xy and 5z, nothing except for 1. And so we're going to use 1 a lot as our greatest common factor as we move forward today. All right, hopefully you followed that along. Take those down, put them in your notes. And so hopefully you got that. Let's move our way through. Our lesson today is talking about factoring quadratics with the a value greater than 1. So going back to greatest common factor review. So now I want you to do the top row, which is red, the bottom row, which is green, the first column, which is blue, and the second column, which is orange. Type the greatest common factor. If you can do this, today is a cakewalk. If you can't, let's walk through this. But if you had no trouble with this, awesome. You got those right answers, way to go. Go ahead and keep moving through here. If not, take a look here. We have these numbers 6x squared and 2x. So what's the greatest common factor? Well, I say that I can find it's either 1 and 6 or 2 times 3. Well, 2 is just 1 times 2. So you find the greatest common number that goes into both of them is 2. Then if I have x squared and x, right, this is x times x, and this is x, and so I can factor out 1x, and so my greatest common factor is 2x. Move on over to the green line, negative 9x and negative 3. Well, always think, can negative 3 go into negative 9? Sure. And so I have 1 and 9, 3 and 3. Here I have 1 times 3, and so the greatest factor here is 3, so I can take a 3, right? And so I can put a 3 here. Now, what's cool is I have a negative in both of them, so I'm going to pull that out too, right? Because I know that I have 2x and negative 3. This is now going to be one of my factors, and this is where we're going today. Now, once you do one side, the other side gets easier. I know this has to have an x, because x and x give me x squared. So 2 and 6, how do I get to that 6? Well, if I look here, my greatest common factor that I can take out is 6 and negative 9, right, is this 3 right here. I can take another 3 out. And then x and x is the x squared. Go to the orange color. And what can I take out of 2x and negative 3? So what's in 2x that's also in negative 3? You can see it. The only thing that they both share is a 1. And so I know that my factors are going to be 3x and 1 up here, 2x and negative 3 here. So if we go to this line, green was negative 3. The red was 2x. The blue was 3x. And the orange was 1. So check those answers, see how you got it. And if you multiply this out, guess what you end up with? You get your 6x squared, that first The middle two terms, negative 9x plus 2x, what do those combine to? Negative 9 plus 2, negative 7x, and then minus 3. So we're going from factored form to standard form, and now we're going to go back. All right. So we're going to start with this problem. I want you to fill these out on the next slide to see if you can do the greatest common factor. So what's the greatest common factor of 2x squared and 10x? Pause it and try this out. Did you pause? Did you try it out? Well, you should have gotten 2x, right? And if you type that in there, now you're saying, well, what times 2x gives me 2x squared? And that answer would be x. And so then what times 2x gives me 10x? 2x times 5. You're nailing it. Check them, loving it, move on over. So now that you have those done, x times what gives me this x value right here? And 5 times what gives me this 5 right here? Hopefully you got that it's 1. Now, and look, we have our factors there. Here's the 5x, x plus 5, and 2x plus 1. So we're going to write that in there. X plus 5 times 2x plus 1. And hopefully you're getting this, you're crushing it, you're feeling good. Keep it up. All right, so we have 3 different trinomial options we've done so far. Where this first value, see the number in front is 1. This one, where the number in front is 2, but we can factor out a 2. So it's really just a scaled up trinomial with a is 1. So this is what we did on Monday. If you haven't done Monday's lesson, go find the video in the lesson and walk through it. Today we're talking about when a is greater than 1, and notice we can't pull out a 2. We can't factor out a 2 from 17 because it's odd, or from 21. So we have to find a new way of doing it. And how do we do that? Greatest common factor. Here's the notes for greatest common factor. At the end of this lesson, there's a link back to your chapter 6 notes. So you don't have to write these down, but you do need to know how to access them. So read through those, and then when you finish reading, pause this, read through them, and join me on slide 13. Once you read this, now we're going to walk through it. So our first steps are to place the x squared and constant terms in opposite corners. So I'm going to place the 9x squared here, and the constant term 4 is going to go right here. Now, in order to find what we're multiplying by, we need to multiply these two diagonals right here, or this diagonal, 9x squared. We did this earlier, and I said, remember, we're going to have to remind ourselves why we're doing this. I want two numbers then that multiply to 9x squared times 4, which is 36x squared. So then we write it in here. What two numbers multiply to 36x squared? Where do I find this number right here? What they add to? Well, what they add to is always this middle term right here, the 12x. That doesn't change. So we're going to write 12x right here. So I need two numbers that multiply to 36 and that add to 12. And so if you like using this diagram, go ahead and write them in here. And ask yourself, which two numbers multiply to 36 that add to 12? So I'm running out of space here, but I always do, what are my factors of 36? 1 and 36, 2. So if you need your calculator, say 36 divided by 2 is 18. Divide 36 by 3, you get 12. Divided by 4, you get 9. Divided by 6, you get 6. So which one of these add up to 12? Yeah, hopefully you can see it's 6 and 6. So 6x times 6x multiply to 36x squared and add to 12x squared. So then I go up here to my diagram. Well, we can redo it down here. And I have 6x, 6x. Those came from the two numbers. And then I just need to use greatest common factors. So go ahead and try that. Pause it, see if you can do it. 9x squared, 6x. What goes into 6 and 9? 3. What goes into x squared and x? X. So I always do this one first, and then I do this one up here. Right? 3x times what is 9x squared? Well, 3 times 3 is 9. X times x is x squared. All right. So what goes into this number right here? 3x times what is 6x? Well, 3 times 2 is 6x. X times x, oh, I don't need an x because I have it over here. Then down here, 3x times 2 gives me 6x. And so just double check this bottom corner. Is 2 times 2 4? Yes. So now I found my two factors, 3x plus 2 and 3x plus 2. They just happen to be the same factor, right? That happens once in a while. All right. Hopefully that made sense to you. I'm going to have you try this on your own. So go ahead and try this problem on your own, pause it, and come back for some guidance. We were able to do this. If not, let's walk through it. I take that 2x squared and I place it right here. I take the 12 and I place it in the bottom right corner. Then when I multiply those two together, I know that I have 2 times 12 is 24 x squared. And that's what I need my two factors to multiply to. So this right here and this right here need to multiply to 24x squared, and they have to add to this middle term right here, which is 11x. So I find all my factors of 24, 1, 24, 2 times 12, 3 times 8, 4 times 6, and 5. Nope, 5 doesn't go into it. So which one of those add to 11? 1 and 24 is 25, 2 and 12 is 14, 3 and 8, that's 11. And so my two pieces are going to be 3x and 8x. So I go ahead and put those in the box, and I think about greatest common factors, right? So what goes into 2x squared and 8x? 2 and 8. Biggest number has to be 2. And then x squared and x is x. You're always going to have an x in this line. You're always going to have an x here. So 2x and x. Oh yeah, that gives me my 2x squared. 2x and what gives me 8x? 4. And x and what gives me 3? 3. So here's your two factors. X plus 4 and 2x plus 3. X plus 4. 2x plus 3. All right. So we have 2 more minutes of this video. And so you're going to walk through slides 15, 16, and 17. And then I'm going to just walk through and show you those answers. This is a challenge problem 5. Go ahead and try that out. And then your assignment is due by the end of the day, Friday. It's Delta Math. And here are the key notes if you want to check those out so you have them saved. All right. Pause this, work through these problems, and then come through for the answers at the end. So hopefully you were able to finish these next 4 problems. I'm going to go through them. You can pause on each slide to make sure that you have what you need. All right. Let's see. So yeah, we already did 1. Here's 2. Again, what factors 2? This is slide 2. Pause it if you need to take a look at it. This is slide 3. Again, you can see it's 2x plus 5 times x plus 3. Here's slide 4, 6x plus 1 times x plus 3. Yeah, if you have any questions on those, you should be joining me in office hours Tuesday morning at 9 a.m. or Wednesday at 3:30. Have an awesome day. We'll see you in class.